Okay, Glenn, so just going to go back over some of the things we did in the class yesterday. And I'm going to start off with the indices, or the powers as we call them. So there's four different rules we went over. There's actually more than four, but we're just going to stick with the four that you did yesterday. They're the ones the most common. So the first one basically is just an example is, for instance, if we have something like this, if we have 2 to the power of 4 multiplied by 2 to the power of 3. Well, how you solve that is you simply add the indices, and so that becomes equals 2 to the power of 4 plus 3, which gives you 2 to the power of 7. And I think, in fairness to you, you seem to be able to pick that one up fairly easily. So I'll do another one. So say we have 6 to the power of 3 multiplied by 6 to the power of 5. Okay. Again, you simply add the indices, so you add the 3 to the 5, and you're going to get 6 to the power of 3 plus 5, and that gives you 6 to the power of 8. Okay, so when it comes to then, if you're dividing using the indices, so we'll say that's with number 2, sorry, say number 3. Excuse my writing once more. So let's say you have say 3 to the power of 6 being divided by 3 to the power of 2. Well, that becomes 3 to the power of 3 minus 2, because when you're dividing, that's the division sign there, looks a bit unlike it, and then you end up with 6 to the power of 6 minus 2, which is 4. Okay, let's just do another one of those. So let's say we have 5 to the power of 4 being divided by 5 to the power of 2. Again, because it's division, you just simply subtract the indices, and that will give you 5 to the power of 4 minus 2 will give you 5 to the power of 2. Now, sometimes you might see the division ones that might be presented, like for instance this one here, you might see it like this. It could be 3 to the power of 6 over 3 to the power of 2. Still get the same answer. You simply deduct the 2 from the 6. That'll give you 3 to the power of 4. Oh, sorry, I just spotted a mistake there, Len. That should be 3 there. Beg your pardon. That should be 3 to the power of 4. Sorry about that. Okay, and this one here could be presented that you could have 5 to the power of 4 over 5 to the power of 2. And that'll give you 5 to the power of 4 minus 2, which is 2. Sorry about that mistake there. Okay, and then the next one we had was the ones in the brackets. And again, I think I picked this up fairly quickly. So we'll say number 5. So in a situation like this, say we had 7 to the power of 2. Then we had a bracket around that. And then outside of the bracket, we say we had 3. Well, in this case, you do actually multiply the 2 by the 3. So that will give you 7 to the power of 2 multiplied by 3, which gives you 7 to the power of 6. Okay, and then just do one more of those. So we had something like 9 to the power of 4 in a bracket, and outside that we have 2. That'll give you 7. I beg your pardon. Get a mistake there. Sorry, Glenn. 9 to the power of 4 multiplied by 2, and that'll give you 9 to the power of 6. Sorry about that. Just simply that once there's a brackets involved, you do the multiplication. And then the last one that we looked at there was just simply, we were saying that anything to the power of 0 is equal to 1. So if, for instance, if you have 8 to the power of 0, that's equal to 1. If you had 120 to the power of 0, that's also 1. If you had 1,647 to the power of 0, that's also equal to 1. So anything to the power of 0 is equal to 1. And then that transfers directly over to algebra. So if you had something like a to the power of 0, that also equals 1. Because no matter what value you put in for a, it will give you 1. So x to the power of 0 is equal to 1. And y to the power of 0 is equal to 1. z to the power of 0 is equal to 1. So anything to the power of 0 is equal to 1. And that really, Glenn, is just the 4 rules of indices. And I said yesterday, I think you picked those up fairly quickly. So I'm going to move on in the next video and do some work on solving problems with linear equations. Okay. So we'll just put a heading on the top of this. So this is the rules of indices. D-I-C-E-S, or sometimes they're called powers. See, both written there. Okay, so that's that, and I'll move on to the next one.